class. So now we come to the third part of the asynchronous lecture, to part of the video of our asynchronous lecture. So in the second part, actually towards the end of second part of our video, there's some technical errors, so I just simply stop. Okay, so now we're going to continue. Only one slide left for this chapter 2, okay, where I have 3 examples to discuss with you here in example 15, okay, which will conclude our discussion on continuity today. Okay, so the first example, number 1, in example 15, the question asks you to find the values of x where the following functions as discontinuous. Okay, we have two functions here, a and b. So the question wants you to identify the point where x is discontinuous. Okay, as you can see for a here, x squared minus 9 over x squared minus 5x plus 6. Okay, and b, we have x minus 5 over modulus of x minus 5. Okay, so if you can see, these two functions both are what we call as a rational function. We have fx over gx. Okay, so if you remember on the properties of the continuity that we have go through before, okay, so this one, polynomial and rational function. A function, okay, just recap back, a rational function, a function of the form p over q, where p and q are polynomials, is continuous for all x for which qx is not equals to 0 or does not equals to 0. Okay, so very simple example that we discuss now. Okay, all meaning that all you need to do is to identify where the point of our qx will become 0. So for example a here, maksudnya our qx is the denominator kan. Okay, qx is the denominator. We have x squared minus 5x plus 6. Okay, so do we have points where this thing become 0? So as you can see, this is a polynomial of factor power of 2, or what we call as a quadratic function. So x squared minus 5x plus 6, you may factor up to x minus 2, x minus 3, right? Okay, so in this case, meaning that we know qx will become 0 if x is equals to 2 and x equals to 3. Okay, so meaning that, okay, understand? We have here, okay, x equals to 2 and x equals to 3 will make qx, or the denominator here, equals to 0. Once the denominator equals to 0, this function fx, or we'll call it, you may call it fx lah, this function become undefined, or fx does not exist. Okay, so meaning that are the points of discontinuity. Okay, because f2 and f3 does not exist. Remember, checklist on the limits, checklist on the continuity. The first checklist is you have to make sure at fx is exist, defined. Okay, fx limit, fx at x equals to a, okay, must exist. So for this case, our a is equals to 2 and 3, and we have found out that f2 and f3 does not exist. Okay, yes, does not exist. So then we know that x equals to 2 and x is equals to 3 are the point of discontinuity for the function fx. Alright. But if you want to go further for checklist number 2, there's no point actually if you want to go further for point checklist number 2, because the function itself is already does not exist. Okay, but this is just a as an exercise for you. Try to find the limit. Okay, does the limit exist or not? This is just untuk kita explore je lah, untuk kita faham. Okay, meaning that this is the answer, but I want to go extra. Okay, let's just find the limit of function ni, x square minus 9 over x square minus 5x plus 6 as x approaching 2, for example. We go first for x equals to 2. So if we put in, remember, for limits, the first thing you try to do is just to put in the value inside. So what will you get if you put 2 inside, class? So you have 4 minus 9 is negative 5 over 4 minus 20. Okay, betul tak? So, minus 10 plus 6. See? What you will get here? You will get negative 5, 4 minus 10 plus 6. So, you will get negative 5 over 0. Betul lah tadi, sebab x equals to 2 will make the function equals to 0. So, you get something over 0 or infinity. Okay, so meaning that here we get negative 5 over 0, or you can say this value is equals to negative infinity. Okay, negative infinity. Alright. Meaning that the limit is not finite. Okay, will results in an infinite limit or limit at infinity and negative infinity. Okay. If you try if you try x equals to 3, what makes the difference? You will get something over 0 as well, kan? You will get, saya tulis kat sini lah, this is just extra lah. Okay, so if you put 3 inside, you will get 0, kan? X square minus 9, okay? X approaching 3, then you will get 0 over 0. So, kalau 0 over 0 ni is, it indicates that you need to do something. Betul tak? Remember, when we have infinity over infinity, 0 over 0, then meaning that the limit may exist. Okay, so for this case, maksudnya kita ada limit x approaching 3, okay, x square minus 9. X square minus 9, we can factor it, become x minus 3 times with x plus 3, right? Okay, and then down here, maknanya kita boleh faktor macam tadi, x minus 2, x minus 3. Then you can see here, we can factor out, cancel x minus 3 and x minus 3. So in this case, kalau you substitute with 3, what you will get? Okay, 3 tambah 3 kat atas tu, you will get 6. Okay, and then 3 minus 2, you get 1. Okay, so meaning to say, for for the function for x equals to 3 tadi, limit does exist, which is equals to 6, but still the function is still discontinuous at x equals to 3, because why? F3 tadi does not exist. Okay, alright, so hopefully all of you clear. Okay, yang merah ni je sebenarnya yang solution kita. Yang biru tadi is just something extra revision for you on how to find the limit for these 2 points of discontinuity. It shows that walaupun F2 and x equals to 2 and x equals to 3 is not defined, but their limits may exist. Okay, alright, so we're done with A. Now we're going to proceed with B. Okay, for B ni pun simple lah. Okay, because we have x minus 5 over x modulus of x minus 5. And I'm sure everyone can guess what is the point of discontinuity for this function. What's the value here? Okay, what makes the function become become 0. Okay, the denominator become 0. Okay, the denominator here becomes 0 when modulus of x minus 5 is equals to 0, right? Okay, and definitely these things become 0 when x is equals to 5. Okay, then we have here point of discontinuity is at x equals to 5. Okay, and again, kalaulah soalan ni saya nak buat revision juga, I change the ink to red here. X minus 5 over modulus of x minus 5, just to find to check on the limits. Okay, x approaching 5. Okay, remember this function is a as a piecewise function. Saya dah discuss, if I'm not mistaken, last week in our synchronous class. If for modulus, maksudnya this function can be interpreted as, okay, x minus 5 if x more than 5, okay, and negative x minus 5 if x less than 5, kan? Okay, if x less than 5. Alright, so for this one, I want to give you extra here. I want you to solve. Okay, try to find what is the limit, okay, when x minus when the x is approaching 5 for x minus 5 over modulus of x minus 5. I want everybody to try and solve this, okay, whether the limit exists or not, okay, and if it is exists, then what is the value. When you look at this, where we have two defined function here, x minus 5 if x more than 5 and minus x minus 5 if x less than 5, meaning that what? We have to consider limits from the left and limits from the right. So go ahead and give a try, okay, and write down your solution as our class submission today. Okay, so this is gonna be your class submission, the first question for our class submission today. Okay, class submission task for today. Alright, now I'm going to continue with number 2. Good. So this is another type of example or questions that make up yang boleh ditanya, okay, for continuity. Okay, another types of question that can be asked for when we want to discuss about the continuity. Okay, number 2 here, for what value of b where it is for what value of b is continuous at every x. Okay, so given to you a function here, gx, okay, where x gx equals to x for x less than negative 2 and is equals to b x square when x is more than or equals to negative 2. The question says here, okay, for what value of b is continuous at every x. Maksudnya soalan ni nak gx ni is defined or continuous everywhere. Okay, so meaning that kita nak kata this function is continuous, gx is continuous everywhere. Okay, everywhere means from negative infinity to infinity. But here you can see our function here, there is a breaking point here. Okay, not to say breaking point lah. Maknanya it is a piecewise function. Gx equals to x if x less than or equals to negative 2 and is equals to bx square if x more than or equals to negative 2. Alright. So for this case, we want to find what is the value of b that will make this function is continuous everywhere. So maknanya kat sini, maybe negative 2 ni akan, kalau kita silap cari or kalau kita silap find the value of b, it will make our x equals to negative 2 as a point of discontinuity. Okay, okay, if b ni is not equals to a particular value that we want to find, then x equals to negative 2 become point of discontinuity. So what is the suitable value of b that will make the function continuous everywhere, including at x equals to negative 2? Okay, so let's find out. Remember to check on the continuity. The first thing is you need to check the value at x equals to negative 2, or whether we need to check. Okay, f at x equals to negative 2, f negative 2. Okay class, so f negative 2, which function should we use, the first one or the second one, x or b x squared? Look at the domain here. X is for x less than negative 2, meaning that does x equals to negative 2 included? No, right? So meaning that it is kita guna second function here, bx square, because this bx square is for x more than or equals to negative 2. Okay, so meaning that here we get 4b. Okay, because we use this bx square. Okay, bx square, we use this one, bx square, then it become 4b lah, because you substitute x with negative 2. Then we check on the limit. Okay, we check on the limit fx as x approaching, okay, negative 2 from the left. Okay, by right, sebab kalau kita nak function ni continuous, maksudnya limit exists, and you have to make sure that limit from the left is the same as limit from the right. Betul tak? Negative 2 from the right, fx, and it must be equals to f negative 2. The third condition, limit exists and must equals to f at x equals to a. At this case, our x equals to a is negative 2. So, here, negative 2 from the left. Okay, saya tak perlu discuss lagi. Negative 2 from the left, maknanya you're looking for the region for x less than negative 2 coming from the left. So, maksudnya kat sini kita guna x lah. So, x, okay, we use x. So, here is negative 2. And from the right, what is our from the right? Then we use bx square kat sini. This is from the right, where x more than or equals to negative 2. So, this one will become 4b. So, C class, f negative 2 also same, which is equals to 4b. So, from here, you will get b is equals to negative 2 over 4, negative 1 over 2. Simple tak? Okay, faham Okay, so ni yang mana, kenapa dapat negative 2 kat sini? Meaning that we substitute with x kat sini kan. And for b, how do we get 4b? Because we substitute with bx square, right? Okay, so when you put in the value, then we compare, then we get b is equals to negative half. Okay, for example 3, I don't want to discuss right now, but instead I want you to solve on your own example 3 as your class submission task for today asynchronous class. Okay, so meaning class, there are 2 questions I want you to solve for today's asynchronous class, where for number 1 is not to solve b, but just find limit for x minus 5 over modulus of x minus 5 as x approaching 5. Okay, I want you to find this. Revision juga ni before you go and solve your assignment. Okay, so x approaching 5, and then the second question I want you to solve for today's asynchronous class task submission is number 3. Try to solve all number 3. Okay, so perhaps during our synchronous class in on Wednesday, we will discuss on the solution. And one more thing, I will also release the assignment at Google Classroom. Okay, maybe tomorrow. So I will let you know in our WhatsApp group when the assignment is already out. Okay, alright, so that's all. With this, we have concluded chapter 2 on limits and continuity. Alright, so hopefully all of you understand and able to answer this class submission questions. Don't forget to submit by 11:59 p.m. tonight. And as I said just now, assignment question will be out soon. Okay, so you I've received all the submission for matrices assignment 1. So meaning that it's now time for you to work out on your assignment 2. Alright class, so that's all for today. Thank you. Assalamualaikum warahmatullahi ta'ala wabarakatuh.